Until recently, when you think of putting things into space, it's multi-million-dollar projects. But instead now, because we have these smaller satellites, students, are able to actually get their hands on an actual device that'll be put into space.
This idea of a small form factor that can perform amazing things at such a small size and low cost, I definitely think it's going to start taking over the industry.
The future of space is definitely looking forward to miniaturization and then constellations and just reducing the barriers for entry into space.
There's no reason to build something the size of a truck when a CubeSat can do just as well.
So the Mighty 1 CubeSat is a 3U cube satellite that has a main body satellite and then a picosat attached to it. In between the two of them, after launch, these two separate satellites deploy from one another using a semi-rigid boom. From here, the purpose is to investigate electrodynamic tether applications.
We can use it to extend the life of the mission or to deorbit.
So this project was actually started with a joint effort through two of the environmental groups on our campus. A PhD student brought a payload to us, and it was our job to build a bus for it. The payload itself is a miniature radiometer, so it's using radio waves to get measurements. This specific one is using resonant frequency of oxygen to get temperature readings.
The satellite that we developed is called Passive Inspection CubeSats. There's actually two twin satellites, and they were developed at Brigham Young University. And so we had the idea to use a CubeSat that is inert, has no capability to maneuver itself, but has cameras on all sides, sort of like a VR camera, so that it could, regardless of tumble, image the spacecraft that deploys it.
We have worked on this satellite for 3 years, hands-on, honestly more than 20 or 30 hours a week, every single week. It just feels really weird. It's a bittersweet moment. However, we are so excited.
It's like the day would never come, and now that it's actually here, it's hard to realize that it's really here. It's really exciting, honestly.
I am unbelievably excited. Like I said, it's been a long time. I myself, tail end of it, but I've still been project manager for a few years now, and we've been waiting. And so finally this is our chance to hopefully get it up there and get some data back.
Everyone on our team is feeling a mixture of anxiety and excitement. So, there's always the anxiety about the launch and the excitement to get up there, but then the real work begins. Can we talk to our satellite, and did we build it right, and is it going to work?
We are PolarCube from the University of Colorado.
We are Mighty 1 from the University of Michigan.
We're PICS from Brigham Young University.